We're doing spinner assignment, what are we up to, 27? Okay, which is basically a straightforward application of the thing we just learned about, just to practice it in another context. And this talk, well, we know the answer before we start. That's the nice thing about this thing. We want to demonstrate that mu1 equals mu2 equals mu3. Now, of course, we can demonstrate mu4, mu5, mu6, but the smallest number that's reasonable is 3. So how do you get your data? So, well, treat the random number table found in the back of the book. We have 2 pages worth of random number tables. But instead of having page 1 and page 2, take page 1, for example, and break it up into thirds, roughly. I mean, it doesn't have to be that exact. And there's a bunch of numbers here, a bunch of numbers here, a bunch of numbers all over the place. And one of the things, what would be the average? Let's say there's 1,000 numbers here and 1,000 numbers here and 1,000 numbers here. What would be the average of those 1,000 numbers? Well, you don't have to answer the question. It's going to be around 4.5. So we know before we start that the 3 sections of the random number table will have an average of 4.5 in each one of them. So take a sample of, let's say, 5 numbers out of this part of the table. Take 5 numbers here, 5 numbers here, and create. That's going to be the raw material. The 15 numbers will be the raw material to actually produce the ANOVA table, with the different columns, the different rows, followed by the F. You make your diagram. Now, this will tell you, figure out how many degrees of freedom there's going to be. Just as a kind of review, what will be the degree of freedom for the F table in doing spinner assignment number 27? Now, you got to give me 2 answers. What will be the degree of, remember the across degree of freedom and down degree of freedom? Yes, Calvin? Nope. Yes, Joe. Across is how? Oh, it's okay. Yes, John. Nope, not 4. What? No, I'm a little surprised not get it. I hope. No. Yes. Hope. What? No. Again, I'm not putting down the form. What was the formula for the degree of freedom among? Just look at your notes. You don't have to memorize this stuff, but it's a quite simple formula. It was almost logical. What's the degree of freedom among? Yeah, so we have 3 columns here, so 3 groups, so it's going to be 2. So it'll be 2 across. And how many down the page? What was the formula there? N minus C, which was 15 minus 3, or 12. So the answer that I'm surprised nobody gave me was 2 and 12. And then you look it up with whatever, I think 0.05 I asked you to do for the spinner assignment, and you get a boundary. And then you make an arrow, and you do it. So that's very straightforward, good practice for the test. The next part of the spinner assignment is the part that we're about to learn today after we finish this thing, is to follow up and do the Tukey-Kramer, which is, we'll talk about that separately, number 28. I'm sorry, 28 says do the same thing, but first do it by hand and do it secondly by Excel. Now here, PHStat works as well, but even I think Excel has a very simple format to doing it without even using PHStat. So here, Excel is pretty good. Number 29 says follow this up by the Tukey-Kramer post hoc test, which we'll talk about 5 minutes from now. And first do it by hand, which is good practice for the test. If you're taking the test in class, then do it by the computer. And finally, number 31, which is a little bit confusing. 31 and 32, which are drop confusing, so let me explain that. 31 says to go back to in the early parts of the spinner assignment. I think it was number 26. Number 26, we had 80, mu1 equals mu2. And we had h1, mu1 not equal to mu2. And you did it by the T formula, x bar 1 minus x bar 2, etc. And you did it by the T diagram. This is repeating that was the last question on the last test, first test. And then finally make an arrow, etc. So if you have an example where you're comparing 5 numbers from one side of the page and 5 numbers from the other side of the page, which is a typical application of Chapter 10, the 2-sample t-test, you do it by Chapter 10. But could you also do it by Chapter 11? Does this formula work? What would be the C? In the case of there's only 2 groups, what would be the C in that case? Roger? What would be the C in the case of 2 groups? No, okay, well, okay. The C is 2, but the degree of freedom is C minus 1, so you're right in that sense. In other words, the point is there's no reason why you can't solve this problem by using Chapter 11, all right? So, in fact, what I want you to do is just solve the problem, I think, by hand, I'm not sure if I told it to do by hand. In other words, just basically plug the same numbers into the F formula. There's nothing wrong. It's just even easier. So less numbers. Plug it into the F formula and solve it. But I only tell you to do it once. I don't tell you to do it by hand or by the computer. So I guess you have a choice. Number 30, this is number 31 now. To do this, take the same 10 numbers, 5 and 5, plug them into the F formula, either by hand if you want to practice for the test, or by the computer if you want to save time. And after all is said and done, you're going to get an F. So if you plug this into, the F formula, you're going to get an F. Okay? Now, do you think there's a mathematical relationship between the T that came out of plugging the same numbers into the T formula or the F that has the same numbers into the F formula? Well, since it's the same numbers and it's the same basic idea, they're not going to come out the same. T and F are not the same thing, but they are mathematically related in the following sense. This is the last item, number 32, I believe. That when you get the T from item number 25, which you should have done already, which should be handed in for today, and you get the F, if you square the T, you should be getting the same as the F. So again, we're not teaching the class from a mathematical point of view, but it's an interesting mathematical result that a lot of these formulas, like for example, the Z is related to the T is related to the F. They're all related to each other in some way because they're all the same. They'll fundamentally boil down to the bell-shaped curve. Okay, that's the explanation of what you're supposed to do for the chapter 11 part of the spinner assignment, except for the part that we skipped just now, which is the Tukey-Kramer thing. So now we're about to begin a totally new section of chapter 11 called the Tukey-Kramer. I really shouldn't say it's totally new because it's a continuation, really.